Hello everyone, my name is Haris, and in this video we're going to be going through LeetCode number 11, container with most water. For this problem, we're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height of I. We want to find two lines that, together with the x-axis, form a container such that the container contains the most water. In the end, we want to return the maximum amount of water a container can store. And we also can't slant the container to achieve a higher maximum. As always, let's go through an example. We're given this example with the corresponding array height. And as you can see, there are the vertical bars that indicate the edges of the potential container. For this example, consider this edge and this edge to be the boundary of the container, and then the entirety of the blue section is the water that can be contained in the container. So we want to maximize the amount of water that we can store in some container given by the edges. It's also important to notice that between two edges that form a container, the height is the minimum of the two heights. For example, if we have the edge A and B, then we see that the height of the container is going to be the minimum of the two. So in this case, it is B. So we simply have to find two edges such that the minimum height of the two forms the largest container for the water. A brute force approach might be to simply find each two edges and check the amount of water that it can store between them. Then we simply take the maximum. However, checking every single possibility will take big O of n squared time. That's because we need to keep a nested for loop to keep track of the left and the right edge. Obviously, we can do a bit better with the optimal solution. And for the optimal solution, oftentimes when we're using a nested for loop, we can replace it using two pointers. So for this example, we can start by initializing the left and the right pointers at the beginning and end of the height array, and simply increment and decrement the left pointers depending on the minimum height. We first calculate the amount of water that can be stored between these two edges. So the water container will be formed something like this. And it will simply contain the width, which is just r minus L, times the minimum height. And the minimum height in this case is 1. Then we can go ahead and increment or decrement the pointer, which is the lower of the two. So in this case, 1 is less than 7, so we increment the left pointer by 1. And then we recalculate the amount of water that can be stored between these two edges. So if we want to calculate the water, it's exactly this blue area. So the left pointer is here and the right pointer is here. So again, we subtract the width, which is just r minus L. And then we multiply it by the minimum of the heights. So in this case, it's 7. And then we update the maximum stored water variable. And we continue this algorithm until the left pointer and the right pointers cross. So that means we've traversed every single element in the array. Now, such an algorithm will only take big O of n time, since we're only incrementing and decrementing the pointers and going over each element one time in the list. Also, the space complexity will be O of 1, since we're not using any additional data structures to store the information. We're just using the pointers to the indices. With that being said, we can go ahead and write the code for this solution. So we're on LeetCode now, and we can start writing the code. So first we begin by initializing the left and the right pointers to be the start and end of the array. So we can simply say L R is equal to 0, which is the start of the array, and the length of the height minus 1, which is the end of the array. Then we can initialize a results variable, and this is what we're going to return at the end. We can write the loop using the 2 pointers, so we can say while the pointers are not crossing, so left is less than right, we can update the results variable, so we can say result is the maximum between the current max, and the formula that we used was the width, which is right minus the left, times the minimum of the 2 heights, so height of left and height of right. Then we can increment and decrement the respective pointers. So we said we want to increment or decrement the minimum of the 2 heights. So if height of the left pointer is less than height of the right pointer, we can increment the left pointer. Otherwise, we'll just decrement the right pointer. And this is the entirety of the code, so we can go ahead and submit. And it's accepted. So this is the optimal solution. Hopefully this video helped you, and I'll see you soon.